When we browse the web, if we enter a wrong website name, or if the site is down for some reason, we often get an error message like this. Although it gives some useful information to us, we generally hate this kind of error. These are not very user-friendly ways to handle an error. Instead, some sites handle such an error in a better way. For example, if we type in some wrong address on Amazon, we get an error screen like this. It shows an eye-catching picture that changes every time, and it makes an unlucky user a little less unhappy. So, errors are unavoidable sometimes in a real-life program, but you can handle them intelligently, in a more user-friendly way. In this class, we will learn about error handling in Python. We have taken a simple program here as an example. This program validates the factors of a number. We are taking one number input from the user, and again we are taking another number here. Then we are dividing number 1 by number 2 and also checking if the remainder is 0. If so, then we say that number 2 is a factor of number 1. Otherwise, number 2 is not a factor of number 1. We will use this program code to learn about error handling in Python. Maybe we can also add one friendly message at the end. A print statement with a message, good day message, have a good day. Okay. So, let us first run this code as it is. We will enter 15 for the first number and 5 for the second number. It says, 5 is a factor of 15 and have a good day. So it has executed this final line after processing the data. Now, if we run this with some invalid input, 15 for the first number, and in the second number we enter 0, it will throw an error, 0 division error, integer division or modulo by 0. It is failing at this statement at this line, because we are trying to divide number 1 by 0. Also check that in this case, or in general also, whenever such an error occurs, the execution stops abruptly. It did not display this good day message here. So the program encountered an error here, and it stopped executing any further statement. So any code that you may have added beyond this point will not get executed. The program will completely stop. But if you wish that, whether or not we get an error here, the program should proceed with the rest of the code since it is not really related to the code above this. We will have to handle this error in a different way, in a smarter way. In that case, this entire code, where we suspect that an error can occur, maybe due to some bad input, or data type mismatch or something, we need to put this code into a try block, to catch the exception. The syntax is really simple. We will just write try, then a colon, and then the entire code that we want to safeguard against an exception. This section of the code must go under the try block. So, we need to indent them as usual, such that they come under the block. By now, I believe you have become comfortable with the syntax of Python code blocks. Now, it will try to execute this section of the code, and if there is an error, it will raise an exception which we need to catch. So, we will say, except. And then, we have to give this exact error name, 0 division error. Remember, Python is very strict about lowercase and uppercase letters. And add a colon. If this exception is raised, we will print a message. Print, then a message within quotes. This print statement will work as a block under the except clause. Division by 0 is not allowed. So, in try block, the code gets executed normally. If an error occurs during the code execution, only then, it will come here and catch the exception which is raised, and it will execute this statement. Then it will continue the program execution, which is the most important thing. It won't stop like this. Let us run this and verify. We will say the first number is 15, and the second number is 0. This time it said, division by 0 is not allowed. So it caught the exception and executed this statement or message. But then it says, have a good day. So it continued and executed rest of the code. It did not stop like this, no error message in red. The overall execution did not suffer because of the division by 0. However, this is not the only error that can occur. We can get an error even in this case, because we are converting the value field directly into an integer, without actually validating the input string. So, it can also get into an error. Let us check that. For this number input, let us type some garbage. Some alphabets. So it went into an error. Value error, invalid literal for int with base 10. In order to catch an exception from this step, we have to wrap these statements also into the try block, like the rest of the code. So, we will remove the try statement from here. And instead of that, we will write the try statement here. Now this entire code will be within this try block. But we have to also indent these lines, so that they come under this block. Please maintain the same amount of spaces on each line. These statements will now execute within the supervision of the try block, and raise an exception if any error occurs. Let us verify if this works or not. So, we will again put a garbage input. As you can see, it again went into the error, the red message, and it stopped the execution, despite the fact that we used a try and except block. This happened because we are catching the zero division error only. But here the error is different. It says, value error. So it is a different error, and we did not catch that. That is why the program execution broke. In order to catch this error, we have to add another except clause here. And after that, we need to mention the corresponding error name, value error. Now, this exception will also get caught, and we will probably print some relevant message here, like, invalid input. Now, this will catch both the errors, and protect the execution from abnormal failure. Let us run this code and verify. We will enter here Python. It says, invalid input, and have a good day, so the value error exception was raised, and it was smoothly caught here. Then it executed the rest of the code. Now, if we try with the division by 0 error, first number 20, and second number 0, we get division by 0 is not allowed, and good day. So in either case, it caught the error through this exception handlers. If you want to display the same message in both the cases, you can write it in a concise form also. We can catch both the errors, or exceptions, in one statement. We have to place them within a pair of brackets like this, 0 division error, and comma, value error. This will catch both the exceptions. We should ideally change this message here, to something meaningful or something applicable in both the error conditions. Something like, wrong input, please, verify. And we do not need the below part anymore. Both the errors will get caught by this single statement. So, as usual, let us run the code and verify. Enter the garbage data again. Wrong input, please verify. So the error is caught here. But if you do not know the error name, or if you want to use a generic catch exception, if you want the program to handle any kind of error that may ever occur, instead of any specific error, we can also use a blank except, like this, without any specific error name. It will catch any kind of error. In this case, we will probably put some generic handling as well, maybe print a message like, an error has occurred. This will be a generic exception catcher that will get hit by any type of error in the code within the try block. When we are using a blank except, please ensure that it is the last except clause. It will catch any kind of exception, so it will catch these two also. If you place it above, the exceptions will hit this one, it won't get a chance to execute this. Once a matching except is found, Python won't evaluate or verify the remaining except clauses. So place it at the end. We can also use multiple try blocks within a program. For example, this part can be separated out, and put under a different try block. So, let us make suitable changes. We use another try here. This try block will take care of this if-else code. And the user input section will go into a different try block. That will be a much better and also more structured way of coding. We have to add an except clause for this try block. Except, : we used a blank except to catch any kind of error in the input. And under this, we will write print, bracket, invalid input. Please try again. We can improve it further by putting this entire code into a while loop, which we learned in the previous class. It will keep asking for the user input until we get a valid input. For that, we will first write the while statement, while true, and then a colon. Now, we have to indent all these lines that we want to include in the while loop. There are better editors that can help you automate these indentations, but I chose this simple and basic editor purposefully because we learn anything better only when we make our hands dirty. Once you get experienced, you can switch over to another IDE. After we get a valid user input here, and there is no error, we will simply break out of this while loop. So we will say, break. Now it will first ask for the user input. And in case of an exception, it will print this message, and again ask for a valid input. Let us run this code and try it. We will give a wrong input, just Python. It says, invalid input, please try again, and please enter the first number. So it is going through a loop. Let us enter 20, and in the second number we enter junk. Invalid input, please try again. Now, if we enter 20, and also a valid number 2 here, it says, 2 is a factor of 20, which is the correct output. So this section of the code is working, once the control comes out of the above try block. Let us also verify if the second try block works or not. This time we will enter the first number as 20, and the second number is 0. It says, wrong input, please verify. So, no error occurred in this try block, it passed this section successfully. Then it went into this section, into this try block, and an error occurred, and it caught the exception here, wrong input, please verify. In this way, you should keep your code within separate try blocks, and handle the error scenarios in a professional way. You can also use a nested try block, which means, a try block within another try block, similar to the nested if-else we have seen earlier. And the last thing is, in a try block, we can also use a finally clause, like this. Just to see how it works, let us add some statement under this. Anything, like a print statement to print, see you soon, in the next tutorial. A finally clause is optional, but if it is present, it will execute always, irrespective of whether there is an error in the try block or not. In case the code executes here successfully, the control will then go to this finally block and execute this. And if there is an exception, it will first go to whichever except clause matches with the error code, and then the control will still go into the finally section and execute this. You can add a finally clause even if there is no except block, it will still execute. Let us run the code. Let us enter 20 and 5. We get 5 as a factor of 20 and see you soon, which means it executed this finally block. Again we will run this code, but with a wrong input. Say 20. And then 0. It says, wrong input, please verify, and also see you soon. So even in case of an exception, it executed the finally block. This finally clause is helpful when you are using a system resource, say you are opening a camera, or capturing the microphone programmatically within the try block. An error can occur in the middle of your processing. In case of a successful execution, you want to close the camera, or the mic, and even in case of an exception, you should close the camera, or the mic. Same is the case when say, you are opening a system file to write something. In those kind of scenarios, a finally blocks helps us to do a cleanup job. We can close or release the resources before we exit from the program. So, through this class, we learned how to safeguard our code from abrupt failure, and how to best handle a known or unknown error scenario in our code. That takes us to the end of this foundation course. You can further check 2 other playlists in this channel, one for Python basics, and another for some advanced topics in Python. I hope you like this tutorial. Thanks for watching, and don't forget to subscribe to this channel.